Hi guys, Ms. Parrish here. Today we're going to look at creating Bohr models and Lewis dot structures. And this is kind of a how-to video. If you forget how to do it, come back to the video and that should remind you how to do these things. Alright, Bohr models are fairly simple. They're a graphic representation of an atom that shows the number of protons, neutrons, and electrons that are in that atom. Here are two different examples of what Bohr models might look like. The one on the left is shows you the different protons, neutrons, and electrons that are in nucleus. On the right, it's just giving the numbers. And the one on the right, it's going to be hard to draw all the protons and the neutrons in the atom. So what we usually do is just add the numbers. How many protons, how many neutrons. Surrounding it, you have your electrons on both sides. And we're going to talk about how the rules on adding those electrons. Alright, so here's your rules that apply to electrons. And we're going to get rid of those two things. They apply to only first 20 elements on the periodic table. So beyond calcium, the rules for adding electrons and the shapes of the energy levels change. And you'll learn more about that when you get to high school. First energy level holds maximum of 2 electrons. Second energy level can hold a maximum of 8 electrons. Third energy level can hold a maximum of 8 electrons. And the fourth energy level for our purposes only involves 2 elements, so those will hold only 2 electrons. This is important to learn. You're not going to be given this information on any of your tests, so you need to learn it. So here's an example of what I was talking about. You have each one of your energy levels can hold a different amount of electrons. This is calcium, and that's our 20th element. First level can have 2, second one 8, third one 8, and the fourth one 2. And here's your protons and neutrons in the nucleus. Fluorine, on the other hand, has 9 protons. That means it has 9 electrons. And so it can have 2 in the first shell. You need a total of 9, so the second one is going to have 7. So here's our template for a Bohr model. We may or may not use all of these energy levels when we're doing this. So we're going to use an example of boron. Okay, we know that boron has 5 electrons, or 5 protons, which means that has 5 electrons. And if we do the calculations to find the neutrons, we discover that it has 6 neutrons. Alright, so when we add electrons to our Bohr model, we're going to be adding them one level at a time. We're going to start off at the 12 o'clock spot here at the top in this first energy level. We're going to add 1 at the top, and then we'll add 1 at the bottom. Okay, that makes this one full, and we're done with level 1. Level 2, we need a total of 5 electrons. We've already put in 2, so we need 3 more. So we're going to start again at the top. We're going to add 1 at the top. Then we're going to go around clockwise, add 1 on the side, and 1 on the bottom. So now we have our total of 5 electrons. That's our Bohr model, except for the nucleus. So inside the nucleus, we need to put our number of protons and our number of neutrons. So there's our completed Bohr model. So just to recap, you're going to add electrons to energy levels from the beginning, levels beginning from the inside out, and at the top going around clockwise, adding 1 electron at a time. You're going to keep adding electrons till you filled up the shell or you run out of electrons. Alright, next ones are Lewis dot structures. They are a graphic representation of valence electrons of an atom. So here is our neon atom, and neon has 8 valence electrons because it's in the noble gases, that last column, and we're going to add them 1 at a time until we get to 8. We add 1 at the top, we're going to go around to the side and add 1 at the bottom on the side, and then we can double up until we get to our 8 electrons. Go back to boron. We have our valence electrons. We should have 3 valence electrons. We'll put 1 at the top, 1 on the side, and 1 on the bottom. So that's as simple as it is for valence electrons.